Hi students, let's look at this question here, which is on um, inequalities or graphing technique. So it's given that this equation here, this curve has this equation, without using a calculator, find a set of values of y, values that y can take. Now what we need to do is essentially to understand that this graph is actually a rational function, right? So when you plot it in your GC, it will look something like that. Now you will realize very fast that you will be able to tell that actually there's a region here which doesn't have any y values, right? So here doesn't have any y values here. So essentially what we need to do is to find the minimum and the maximum point. In fact, you could dy dx equals 0 to find this point here and here as well, okay? But the you can't do that because they're saying that, oh, actually you could without using calculator. Okay, great. So if they say by using algebraic method, then you can't. Okay, actually one of the way you could do it is to just dy dx max and min point and could just find it. But this juncture here, what we can do is just use discriminant. We're just gonna create a proxy horizontal line, and we know that this would not give any real solution here. Then this will give exactly one, and there are two solutions here. Okay, now at get-go you should understand that discriminant is not the you wouldn't know that it's discriminant until you are told to solve a quadratic equations. Okay, so but that's the whole idea there. Later on, you know that it can be reduced to a quadratic equation. Then you use discriminant. All right. So that's what we're gonna do. So this case here, I'm gonna let I'm gonna use the more lengthy way to solve this. You could actually let y equals to k. You just pretend that y is a constant, and you can just use the discriminant straight. But what I'm gonna do is I'm gonna let y equals to k. Be the horizontal line, okay, where k is a real value, so that we need to find the real value there. So then we're just going to sub y equals to k into y equals to x squared plus x plus 1 over x minus 1. Then we're going to do just k equals to x squared plus x plus 1 over x minus 1. Now this case here, I think you can just use dy dx. If you I mean, you can dy dx equals 0, you find that it works as well. But this case, I'm not going to do that. I'm going to use discriminant. So x squared plus x plus 1 will be x squared plus 1 minus k. I'm just going to... is alright? So just this form could be reduced to this. So this x, yeah, that's it. Then what I'm going to do next is, because this is a quadratic equation, and because since there's y value, since y value can take, this will imply that there are real solutions for x, for this equation, or rather for the equation, real solutions for this equation. So essentially, we know that discriminant b squared minus 4ac would be real solutions. Real solutions will just means that we have at least 0, right? So the horizontal line can actually cut it once or cut it twice. Okay, so there are these two juncture here. So this case here, I'm going to put is 1 minus k square minus 4 times 1 plus k. Then I'm going to just solve this. So it's k square minus 2k plus 1 minus 4 minus 4k. This is 0. K square minus 6k minus 3 bigger than 0. Okay. This case here, I think we could just use, do you want to find exact? Yeah. Without using calculator means we can use exact. So solve for the roots here. So that will be k is actually minus negative 6 plus minus b square minus 4ac over 2a. Okay, then just key in calculator. 6 square here, there'll be 6 square plus 12, that will be 48. Yep, 6. So there will be 6 plus minus root 48 over 2. Then from here, what we can do is just 48 divided by 4. I think we divide by 4 twice. Yeah, so 16 48 divided by 16 will be 2, so that will be 6 plus minus 4 root 3, or 2, that will be 3 plus minus 2 root 3. Okay, so when you solve this inequality here, just be careful. What we have here is essentially 3 minus 2 root 3, 3 plus 2 root 3. Okay, so check. You can use your GC and check the turning point here. So this turning point, this should correspond to what we found here early on. So I'm just gonna check my answer by 3 minus 2 root 3. So is that the answer? Yeah, there you go. You can actually check answer in exam. Just be mindful of that. Then 3 plus 2 root 3 plus 2 root 3 is 6.4. Yeah, there you go. Great. So there you go. So we are finding this range here. So hence, k is at least at most 3 2 root 3, or k is at least 3 plus 2 root 3. Okay, so y values is set of values. So set of values of y, set of values of y can take is actually y real value, and where y is at most 3 2 root 3, or what, or y is at least 3 plus 2 root 3. Okay, so that's that. So if any questions or comments, please do let us know, and I'll see you in the next question.